Welcome to a lesson with Dr. Powell. Let's take a look at the acceleration function for a position function and find its tangential and normal components. So what's acceleration that's in the direction that's tangent to the curve, and what's the acceleration that's normal to the curve? It's perpendicular to the tangent. Okay, orthogonal to it. Okay, so we're going to look at the function cosine t, sine t, 2t. Now, in order to compute this, so we're going to find out what goes here, and we're going to find out what goes here. Now, remember, what goes here is simply going to be, you take the length of v and you take the prime of it. Really, it's the second derivative of s, where s is arc length, kind of the length of path as you're going in along the curve. Okay, so this is what we're going to compute, and that's going to be the tangential component right here. So we need to be able to, first, let's find v. So it's negative sine t, cosine t, 2. All right, next, let's find v right here. The absolute value is going to be the square root of, the square root of sine squared plus cosine squared t. And then we have plus 4. Okay, so that's going to end up being just 1 plus 4. Take a square root. And so we end up getting just the square root of 5, which is a constant. So when we take a derivative with respect to t, we're just going to get 0. So this part just zeroes out. That means that the acceleration vector itself is actually going to be in the direction of n completely. So we're done if we just compute the acceleration vector and itself, and even find its length, and then we can just multiply it to n because it's going to be in the direction of n. So if we go ahead and compute the acceleration vector, let's see what we get. So the acceleration vector is just going to be negative cosine t, negative sine t, and 0. And this vector has length 1. If you work it out, cosine squared plus sine squared is equal to 1 square rooted. So really, the acceleration vector itself is just equal to n, completely and totally, for this helix. Thanks for watching.